page 6. We talked about one-step equations. We looked at when you have fractions in the way of a one-step equation. We decided that there's two ways to solve it. You can make it into a two-step equation, or you could multiply by the flipped fraction, and that gets rid of it. And then it's just a one-step equation. Okay, now let's come down here to two-step equations. So we have two-step equations here. If you already know how to do this, you're welcome to take off with it. I'm going to give some advice and tips as I'm going through if anyone's struggling. So drawing that line, focus your attention on where the variable is. I do need to refresh you that, or I want to remind you that when you are solving a two-step equation, this 6x term right here, I cannot move that or deal with the 6 until I get rid of the plus 8. So you have to move all addition and subtraction stuff away, and then you focus on any coefficients, numbers in front of the variables, last. Let me show you this. Okay, so write this down. I know you've seen that before. PEMDAS. Skylar, are you with me? We've got page 6 out. We're on page 6 from yesterday. And then if you'll go ahead and make the exchange for a calculator. So PEMDAS, that's the order of operations. Please excuse my dear Aunt Sally, as a lot of people say it. I wanted to show you a different way to see it written. When you are simplifying, meaning just trying to clean it up, you go in the direction that you may recall from middle school. You take care of any parentheses first, and then you take care of exponents. Multiplication and division are written side by side because they're interchangeable. You read it like a book. It's whatever you come to from left to right. Addition and subtraction is the same thing. It's interchangeable. It's whatever you come to from left to right. Now, when you are solving, here's why I wanted you to write this. When you're solving, it's a reverse concept. We are going to move away all addition and subtraction stuff first. Then we're going to take care of any multiplication and division. Okay, so it's kind of the reverse order of operations. So looking at this, I need to get rid of this 8. The only way to do that is to subtract it off. And then if I will show my work, I know exactly what to type in the calculator. I see 50 minus 8. I also see that there's a 6x left here. Right? And then now I have a one-step equation left to finish solving it. 6 times x, so the opposite would be divide x, 6. We end up with 7. Now, let me show you a really cool little way to check yourself. I got to say it before you wreck yourself, right? So, because it's an equation, do you remember what you can do to make sure it's right when you come to an answer? Anybody ever taught it to you? What? That's it. Say it louder. There you go. If you come to an answer and you're unsure of yourself, just plug it in, because that's how you know if you get it right or not. So come up here. I'm going to write the word check. I'm going to check myself. I'm going to plug 7 where I see an X. And you don't have to show the work of plugging it in. You would just go to your calculator and type it in. So basically, you type one side in and confirm if it's the same number as the other side. So you'd go to your calculator and type 6 times 7 plus 8, hit enter, and what number should we get? 50. And then you would. So you would know, okay, yeah, that's right. It checks out. So if you do come to a number that you're worried about, plug it in and see if it's right or not. You can, I personally in math, because there for a while I did struggle a little bit until I got a tutor and then all of a sudden it clicked. I liked when I knew that I could plug it in. I needed that confidence booster before I went to the next problem. All right, so let's look at 10. We're going to draw our line down. We're going to say, okay, this is the letter I need to get by itself, the variable. We're going to move what first? What's going to go to the other side first? The -5, and it would move by addition. So if you'll show your work, I know you don't want to write, but at least we're not writing essays, right? Can we all just take a second and appreciate the fact that I'm not making you write an essay in math? You know why I'm not? Because one, I don't want to grade it, and two, I don't like writing essays myself. But please write your work for the math, if you don't mind, because if you get it wrong, as I'm coming around, if you've got your work, I can look at it and I can pinpoint exactly where you went wrong, which means I can help you. All right, so we're going to add 5. 2n would be left. 16 would appear on the right. Then we divide by 2, and we get 8. Now, having said show your work, the goal is eventually you wouldn't need to show as much work, right? That's the goal. So I'm going to answer number 11 with the way that I show my work on my paper. I come over here and I say to myself, okay, I'm trying to get K by itself. I still sometimes just kind of acknowledge what I'm getting by itself. So I move the 9, I strike it out, and I'll come over here and say it's going over there. Right? We get 4 equals -4k. And then I know that I'm moving the -4. It's attached by multiplication, so I move it by what? Division. And I just come over here and say negative, so I get -1. So that's another way to show your work, but it doesn't require as much writing. But that really requires you to know what you're moving where. The other methods of showing your work is requiring you to put it on both sections, and that's in case you struggle with making mistakes along the way. Once you start fine-tuning those skills, you could do something like this. Everybody try number 12. Spot check real quick. All right, you should have gotten -9 here. You would subtract the 7. So this is a little tricky. I've seen people mess up before when it looks like that. They associate this negative here with the number that's actually in front of it, and so they add 7. If I add 7 here, that would become a 14, which means I've not done anything to help myself. I need that to go away. So it would be -7. And then 34 minus 7. And then we're going to divide by -3, and that's where you end up with -9. All right, go to the back. let's look at 13 through 18. Go to the back. We've got the same type of problems, but this time they have fractions in them. Don't let the fractions scare you. We talked yesterday about how to handle them. Either turn it into a two-step or multiply by the reciprocal, right? Okay, so on 13, the goal is to get this by itself. You can't do anything with that divide 2 until you get rid of the minus 7. So we're going to take that minus 7. We're going to add 7 to both sides. I've got x over 2 left. Then I see clearly that I've got 16. And then what's the opposite of divide 2? Multiply by 2. So I'm going to multiply by 2, but whatever I do one side, I got to do the other. And I get 32. You try 14. You should get negative 15. You try it. Michaela, did you check in through the front office? Okay. Do either of y'all have your syllabus signed by chance? Okay, I'll text you tonight. Bless you. Okay, that's enough. And then multiply by negative 5. So you get negative 15. Again, now that these are getting a little bit dicier, I guess you could say, when you come to an answer, just go to your calculator and type one side in, the side you got the answer with, negative 15 divided by negative 5 plus 8, and see if you got it right or not. And actually, let me pull my calculator up because I think some people need a refresher on how to type a fraction in. Let me find my calculator. Oh, okay, there's two ways. There's two ways to type a fraction in your calculator. One way types it out like linear, in a line, in a straight line, which bothers me because fractions go what direction? Up and down, right? You have something like this over a number. So there's two ways to type a fraction. You can type it out in a linear fashion where it looks like this, or you can type it in a stacked fashion where it looks like that, which is what I prefer for me because I like to see the fraction and sometimes I'm worried I'm going to mess this up. So I'm going to show you both ways to do it. The linear, like out on the same line fashion, is just as simple as typing, I'm just going to make one up, 4 divided by 5. Like that's a fraction. There's a problem. There's a caveat. Caveat meaning like, watch out, there's something you got to be careful for. If we have more in the fraction, then order of operations comes into play. Like that is just 4 divided by 5. But if there was more in there, like maybe 4 squared divided 5 x to the third power, you know what I mean? Like if there's more stuff in the fraction, you have to put parentheses around it to tell the calculator this fraction is literally just 4 over 5. Or if there was more stuff there, let's say it was 4 over, and then on the bottom, maybe 5 times 3, I don't know. You would need to put the 5 times 3 in its own parentheses. And that's where it starts to get really complicated. That's why I don't like that technique. But it works. You just have to watch parentheses. Now, let me show you this. This is my favorite. It's 2 buttons. Alpha, y equals. That menu pops up. You will notice it says n/d. That means numerator over denominator. And if you hit that, it's going to give you boxes in that stacked form. And you just type them where they go, the numbers where they go. So I type 4. I need it to go to the bottom. I'd arrow down. I'd type 5. And it's the exact same thing. The other nice aspect of the stacked math print form is if it's a fraction that will reduce, because you typed it in as a fraction, it's going to return it as a fraction. So let me show you what I mean by that. Well, this is let's do one that reduces. Let's do 8 over 10. Okay, so alpha, y equals 8 over 10. And now let's do 8 divide 10. All right, look at the difference. I entered 8/10. When I entered it in stack form, the calculator reduced it for me and kept it as a fraction. When I entered it in that linear form, line form, it only reduced it, or it only spit it back to me as a decimal. So the Delta Math assignment from yesterday, you should have noticed the last 2 or 3 questions were fractions. They wanted the answer in simplest fraction form. So if you ever see answer in simplest form, then this is what they're talking about. You may come to 8/10 as the answer, type it in your calculator, but you need to type 4/5 on the assignment, okay? So let's do this so that you have a place to reference. Go over here to this open space right here. Let's write CALC for a calculator tip. And we're going to write alpha y equals. And then you get n divide d. And that's where you're going to see box over box. Alpha y equals n over d. And you'll see that stacked box form. Now, one more calculator tip. What if we're solving something and it's already in decimals, but the directions say give it to me as a fraction? How do you change from a decimal to a fraction on these graphing calculators? It's really easy. So I'm going to, let's see. I'm going to draw a line to separate, 2 lines to just kind of separate. Okay, so here's a different tip. DEC to FRAC. So if you need to convert from a decimal to a fraction, here's what you type in the calculator. CALC, ready? Math, frac. You're going to hear me say that quite a bit. Math bracket. That's what I'm going to say. It means push the math button. The very first option says fraction. You'll hit enter, and it will take whatever decimal you had and turn it into a fraction. If the decimal will not convert to a fraction, it will just spit the decimal back at you. So I've had people say, it's not working, because it just kept giving them a decimal. That's because that decimal doesn't go to a fraction. If you recall learning about numbers, there's what's called irrational numbers. I always think of it as like a person who cannot be reasoned with. It's a number that cannot be put in a fraction form. Okay. All right, so hopefully that helps. and try to memorize those steps. I'll remind you. I also have it right here if you ever need it. And I'm going to try to make little, I may laminate them, I don't know. I was going to try to make little cheat sheet. I guess like a little card with those steps on it. All right, let's look at 15. We're getting x by itself right here. We need to move, as we've talked before, that all addition and subtraction stuff has to go first. So I'm going to subtract 22. That leaves me with a 3/5 x equals, and I get 6. Now I need to get rid of the 3/5. Go back to what we did yesterday. You can either do 2-step here or 1-step. 2-step would be multiply by what? 5 on both sides, then divide by 3. 1-step would be to say, okay, I need that 3/5 gone. I'm going to multiply by 5/3. And whatever I do to one side, I got to do it together. Because right here, I would end up with 15 over 15, which is a 1. Someone in 4th block yesterday said, I did it a totally different way and I got the same answer. And it's always funny when people say that because they think they've found like some secret passageway or something. When you see 3/5 times x and you're trying to get x by itself, some people look at it as, okay, I need to divide by 3/5, right? There's nothing wrong with that. That's not like a secret. Yes, you do need to divide by 3/5. But in middle school, do you remember something called keep, change, flip? Do you remember that? Basically, in middle school, you learned that there's no dividing fractions ever. You don't actually divide anything. You keep, change, flip, and multiply fractions, right? So instead of saying we're going to divide by 3/5, oh wait, no, we're going to keep, change, flip. That's like 4 concepts. We're in high school now, so instead of going through the whole divide by 3/5, we're going to go ahead and jump to the, I'm going to multiply by the reciprocal, which is the change, flip part of keep, change, flip. We're already doing that. So when I multiply by the flipped fraction, I am already finishing that process of keep, change, flip without the elementary aspect of saying keep, change, flip. Okay? But you get the same answer. So in your calculator, you would type 6 times 5/3, and because of how I have it written on my paper, I want to see it exactly like that. So I'm going to type 6 times, and I just learned the fraction shortcut, alpha y equals 5/3, and I get 10. So x is 10. 16 through 18, please do those right now, and I'm going to come by and check it. You should get the following answers. And then I need to talk to you about the bottom 4, and then we'll move on to our practice. Okay, let me get my pencil. Okay. out that negative. So these are actually opposite sides. There you go. And that's going to change it. Right. And do these three for me. Oh, okay, so when you were to flip the fraction, yeah, you gotta flip it. Otherwise, you, over here, would end up with just a bigger fraction. Let me see. Okay. Perfect. Okay, you are right, and you are going to come to this answer. There's a step in the middle, because you see how this is negative? So what you could do is, when you move the 3, you can assign that negative to the 3, and then that would disappear it from here, and then now you can come to that answer. Does that make sense? All right. Okay. I'm just watching the buttons here. Okay, and then just bring that down. Right. Yeah, you're good. No, this is gone. You took care of it. Now you're just going to copy that down, and now you're going to take care of that. Bam. Got it. Do you have any questions? Do you remember this? Is it coming back to you a little bit? Or maybe it's ringing a bell better because I'm a better teacher than your Algebra 1 teacher. That's terrible. I was kidding. Look at the bottom 4. So this is a little different, which is why it's in its own little section. We notice it says watch out. Makes me think of the GPS, watch out, hazard on the road ahead. Let's draw attention to this. Watch out. Let's make a note. This is a bigger fraction. This is a much bigger fraction. This is not just one little fraction stuck next to the variable. This is a giant fraction. So, look at the difference. Let me scroll a little. Look at the difference in 17, the fraction in 17 compared to the fraction in 19. In 17, the 4 is only underneath what? The 7. But in 19, the 8 is underneath x plus 11. That's more stuff, right? Those are called terms. Terms just means parts of an expression. Terms are always separated by plus and minus signs. And so there's 2 terms here. Up here in number 17, there was just the 1 term. So that's the difference here. So you cannot come in here and take care of that plus 11 because it is attached to the x stuck in the top of the fraction. So what you have to do is to recognize, okay, wait a minute, this entire thing is divided by 8, so what would undo that? Multiply by 8, right? So we're going to multiply the whole thing times 8, and that's going to go away. As ugly as that looks, it'll go away. That's by design. Now, whatever you do to one side, you got to do to the other. So what starts out really ugly and then looks even uglier when I try to go in and show my work leaves me with just the top part, and then over here I have to multiply by 8. And now I have a nice pretty equation that looks like what we practiced on the front of the paper, because there's just one step to solving it left. And so I would subtract 11 from both sides. I would like you to do 20, 21, and 22. I'm going to show you the answers to make sure you get it right. You're doing exactly what we just talked about. When you finish the bottom 3 problems, bring me your paper and I'm going to give you page 7.